Let's jump right in. Welcome to The Explainer. I am absolutely thrilled to share this visual journey with you today. We're looking at the August 2026 cinematic lunar eclipse. We've got some truly stunning details from our sources, and we are going to transform them into a premium space documentary right here, right now. Just picture this setting in the deep, silent expanse of space. A massive umbral shadow moves ominously toward Earth's shining moon. It's one of those breathtaking moments where the sheer, mind-boggling scale of the cosmos just reveals itself right above our heads. So let's dive into exactly how this works. Part 1. What is a lunar eclipse? To really visualize the 3D geometry of what's happening here, imagine this. Step 1, the Earth moves directly between the sun and the moon. Then, step 2, our home planet actually acts as this giant cosmic shield, totally blocking the direct sunlight that usually lights up the lunar surface. And finally, step 3, a massive shadow is cast across the moon. We're talking about a deep space alignment of incredibly massive celestial bodies, all moving at thousands of miles per hour and syncing up perfectly. Moving on to part 2, why this one is partial. Now, the umbra is the absolute darkest central part of Earth's shadow, where the sun is completely blocked out. But because the three-dimensional alignment of the sun, earth, and moon isn't, absolutely perfect this time around, the moon isn't going to slip fully into that dark center. Instead, it's also going to pass through the penumbra, which is the fainter outer shadow. So a tiny bright sliver of the moon will actually remain outside the absolute deepest shadow, making this a partial rather than a total eclipse. Part 3, the August 2026 event and who gets the best views. Now, what's really interesting here is how visibility breaks down globally. The Americas hit the absolute sweet spot for this event. They get excellent visibility, with the entire eclipse happening high up in the sky near maximum eclipse. Now, if you're in Western Europe or Western Africa, you're getting a highly dramatic, almost cinematic, low-horizon view right before moonset or dawn. But unfortunately for our friends in most of Asia and Australia, the moon is just going to be below the horizon during the event. Of course, knowing where the moon is in the sky is literally only half the battle, right? You desperately need clear weather. And here's a really cool detail from our sources. A summer heat dome is likely to be anchored in the southwest US. Weather patterns like this actually stop clouds from forming, meaning folks out in that region are highly likely to have perfectly clear, pristine skies for optimal viewing. Part 4. Journey through the shadow. Let's look at the timeline. This whole journey kicks off quietly at 0124 UTC when the faint penumbral phase begins. But the real visual drama, that starts at 0234 UTC. That's when the dark, partial umbral shadow takes its very first visible bite out of the lunar disk. We hit the spectacular maximum eclipse at 0413 UTC. Then the partial phase ends at 0552, and the whole shebang wraps up at 0702 UTC. Start to finish, you're looking at about 5 hours and 38 minutes of a truly majestic celestial transit. If you're planning to photograph this, you really need to heed this brilliant advice from the source material. It says, the brightness changes more than many first-time eclipse photographers expect. The moon loves to humble people with cameras. I just love that. It's a wonderful, slightly humorous reminder. You really can't just set your camera and walk away. You absolutely need a sturdy tripod, manual focus, and you've got to be ready to constantly tweak your exposure and ISO settings as that creeping shadow dramatically changes the lighting. Part 5. Why the moon turns red. I want to pose this question directly to you. Why does the eclipsed moon turn a coppery red color instead of just going completely dark? I mean, think about it. If the Earth is a solid object blocking the sun, shouldn't the moon be completely pitch black? The answer is actually incredibly poetic, and it all comes down to the physics of our very own atmosphere. So as sunlight hits the edges of Earth's atmosphere, it gets filtered. Shorter blue light wavelengths scatter super easily. That's a process called Rayleigh scattering, which, by the way, is exactly why our daytime sky is blue. But the longer red light wavelengths, they push right through. They filter and bend through our atmosphere, projecting outward and painting the eclipsed moon in these warm, rusty tones. You're essentially seeing the projection of every single sunrise and sunset happening all at once, all around the Earth, cast simultaneously right onto the lunar surface. How cool is that? Part 6. A rare deep eclipse. 96%. At the exact moment of maximum eclipse, a staggering 96% of the visible lunar face will be plunged into the dark umbra. To put that into perspective, it's an incredibly deep partial eclipse, almost total. Plus, this event is a proud member of the Ceres 138 series. Eclipses in this specific cycle only happen once every 18 years, 11 days, and 8 hours. It's actually the absolute deepest partial eclipse we'll have seen for over 2 years. Because 96% of the moon is covered, we get what's called an almost blood moon. It creates this intense, absolutely gorgeous contrast between that copper-red expanse and the tiny, blindingly bright silver sliver of the sunlit edge that remains. And if you miss it, well, you won't see another 96% coverage event until December 31st, 2028. It is for sure a must-watch. Part 7, our final cosmic reveal. Just zooming out for a second here. The sun, the earth, and the moon are all engaged in this delicate, precise, and perpetual orbital dance. What we get to observe as a beautiful, glowing red disk in our night sky is actually a flawless demonstration of celestial mechanics. We are sitting on a rocky planet, casting a massive shadow perfectly onto our natural satellite, completely driven by the gravity of a star millions of miles away. It's just breathtaking to think about. So, the crucial point is this, and I really want to leave you with this final provocative thought. Next time you look up at a seemingly still night sky, will you remember the massive, precise cosmic machinery constantly moving just above your head? I truly hope this explainer has brought that beautiful reality to life for you. Thank you so much for exploring the cosmos with me today. Keep your eyes on the skies, and I'll see you in the next explainer.